All right, I'm going to do two problems now. They're both on page 12, numbers 2 and 3. So number 2 says, zinc and sulfur react to form according to the equation. And I give you the equation. Zn plus S, sulfur is not a naturally occurring diatomic. Zn plus S is ZnS. So zinc 2 sulfide. Okay, so there's your reaction. 1, 1, 1. It all balances. Okay, so if you have 25.0 grams of this and 30.0 grams of that, the first thing it is asked of you in letter A is what is the limiting reagent? So the first thing we got to do is you got to take this 25.0 grams, 30 grams, turn it into moles. So we take 25.0 grams and to turn it into moles, according to the flux capacitor, we divide by the molar mass, which is, for zinc, 65.39. You do the math on that, and you get 0.3823 moles of Zn. Now, when I look at moles of Zn, and I look at the balanced chemical equation, there's a 1 right here. So I can divide this by a 1, but you're going to be 1 to 1 anyway. So you don't have to do anything like you've had to do on other problems. 30.0 grams of sulfur, however, is divided by, and by the way, that was zinc. This is sulfur. I think it's 32.07, yep. So 32.07. So when you divide this out, you get 0.9355 moles of sulfur. Now when I go to compare these, again, it's 1 and 1, so I divide this by 1, divide this by 1, and you find that the smaller one is this by a lot. So we're going to run out of zinc way before we run out of sulfur. Letter B then goes on to say this. How many grams of this zinc sulfide will be formed? In other words, what's the theoretical amount? The perfect mass. Well, we said we're going to run out of the zinc first. So we start with 25.0 grams of what we're going to run out of, which is zinc. First thing you do, turn it into moles so that we can do a mole ratio. There are 65.39 grams of zinc and 1 mole of zinc. Right? Then from there, what you're going to do is you're going to compare moles of zinc to moles of what you want to know, right? Here's your mole ratio stuff. We always have on the top what we want to know. In this case, we want to know ZnS. Well, the numbers is 1 and a 1 there. So it's 1 to 1. Then in 1 mole of ZnS, it has a mole ratio, grams of ZnS. And that ratio is 97.46 grams. 97.46 grams. That is not a 1, that's just the divider there. 97.46. Well, you do the math across the top, do the math across the bottom. We have 3 standard figures here to start. Therefore, you have 3 standard figures in your answer. The answer is 37.3 grams of ZnS. Question, or letter C says, okay, how many of the excess will there be? Well, again, we always start with the limiting reagent. So it's 25.0 grams of zinc, right? Then from there, we know there's 65.39 grams of zinc. Notice we're doing the exact same thing we did in the last problem. We're going to keep doing the same thing until we get to the mole ratio. This one we want to compare moles of zinc, right, so that we can cancel here. But we want on the top something else. Now we want to know how much of the sulfur is left over. So it's moles of S. Well, it's 1 and 1, so 1 and 1. And then in 1 mole of sulfur, we established right here it's 32.07 grams of sulfur. You do the math on that and you get 12.3. 3 standard figures, 3 standard figures, 12.3 grams of sulfur. But that's what's used up. This thing wants to know how much excess we have, right? So what we end up doing is we end up then saying, okay, we had 30 grams to start. We only used 12.3 of them. So 30 0.0 minus 12.3 equals, tens place, subtraction rules, you get 17.7 grams of sulfur. And that is the answer to letter C. Okay, now let's do number 3. Number 3 says, which element is in excess when 3 grams of magnesium is ignited with 2.20 grams of pure oxygen? So, which one is in excess? So first of all, we have to write an equation. Magnesium reacts with oxygen, O2. This is a synthesis reaction. We're going to take two things and put them together. We're going to make Mg and O. Now you may say to yourself, well, wait a minute, Mr. Gerber, there are 2 of them, right? Well, magnesium is a +2 charge, oxygen is a -2, so that's the proper way to write magnesium oxide. Where we're going to deal with the fact that we need 2 of them is, we're going to put a 2 right there, that gives me 2 O's and 2 Mg's, so you need a 2 right there. Now, once in a while, the magnesium and the oxygen, which of them is in excess if we have 3.00 grams of this and 2.20 grams of this? Which one is in excess? Well, here we go. 3.00 grams divided by the molar mass of magnesium is 24.31. This is Mg. And you get that number, and that is equal to 0.1234. Interesting. And then you take 2.20 grams of O2. Yes, it's O2 here. So it's divided by 32, right? Because it's O2. So you end up with 0.06875. Now, you might be inclined to right away say, oh, it's easy, Mr. Gerber, that one's the bigger one, it's the excess. But here's the problem. We have one of these for every 2 of these, and so we got to account for that. We're going to go through twice as much of this as we are this. We can divide this one by 1, but we got to divide that one by 2. When we do that, we get 0.0617 moles of Mg. When we do this, we get 0.06875 moles of O2. Uh-oh. If you would have forgotten to do this, you would have gotten the problem wrong, because the excess is the bigger number now, right? We're going to run out of that one first, because 0.061 will run out before 0.068. It's not by a lot, but your excess is that one. Now, the second problem here says, what mass is in excess? Well, we got a couple of problems here, okay? First of all, it is always the limiting reagent that determines when things stop. So we start with the limiting reagent. So we're going to start with the limiting reagent, which is 3.00 grams of Mg. That's kind of weird, but it is what it is. How many grams of Mg in a mole of Mg? Well, we can go find that particular information on the periodic table, and that is, what is it? (24.31). Right? So then we keep going and we look at now our mole ratio step. Well, what we end up looking at is we want to know now our excess, how much of this 2.20 grams is left. So we're going to compare moles of Mg to moles of O2. Well, we go find the numbers. There's a 1 right there, so a 1. And for Mg, there was a 2. Well, I want to know mass, right? So in 1 mole of O2, there is 32 grams of O2. Moles cancels moles, moles cancels moles, grams cancels grams, leave me grams of O2, right? If you do the math going across, and it's 1.97 grams of O2. But remember, that's how much was used up. So, I gave you 2.20. You used up 1.97. So the answer is 0.23 grams of O2. Now, this problem actually doesn't just ask you for that. It also says what mass of MgO is formed. So you have more to do. You got to do another one. So 3.00 grams of Mg. In 1 mole of Mg, there is 24.31 grams of Mg. Brings us to our most important step, mole ratio. Well, here we want to compare moles of Mg to moles of what we want to know, which in this case is MgO. Right? Well, you go find the balanced chemical equation for the numbers. There is a 2, so there's 2 moles of MgO for every 2 moles of Mg. Now, some people would say, Mr. Green, can I make that 1 over 1? The answer is yes, if you want to. It's up to you. And in 1 mole of MgO, there are how many grams of MgO? Well, you go find the molar mass of MgO, and it's 40.31. Okay, 40.31. You do the math across top, math across the bottom, you divide them all out. You started with 3 significant figures, you finished with 3 significant figures. The answer is 4.97 grams of MgO. And all of this is required for problem number 3.